Day 334 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 7, reverse integer. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible, y'all. But before we get started, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the signed 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the signed 32-bit integer range, then return 0. Assume the environment does not allow you to store 64-bit integers signed or unsigned. All right, y'all, that sounds simple enough, but it's a medium problem, so you know it's never that simple. There's a few things we have to keep in mind when we are solving this problem. One, we have to keep in mind it has to stay inside this 32-bit integer range, and if not, then we return 0. We also have to be able to handle cases with negative numbers, and we have to be able to handle cases with 0, because as you can see, if you reverse this number 120, after you reverse it, it's 21. It's not 021. So let's go ahead and take a look at these examples just to make sure we completely understand what is going on here. Now, in example 1, we have x equals an integer 1, 2, and 3. The output is 3, 2, 1. Sounds simple enough, right? We just take 1, 2, 3, reverse it. Now we have 3, 2, 1. Same with example 2. So example 2, we also have an integer negative 123, but when we reverse it, it's negative 321. So you notice the negative sign doesn't move. We're not moving the negative sign to the end or getting rid of it. We still have to keep the number negative. We just have to reverse the integers associated with that negative sign. Then similar in example 3, like we went or like we talked about earlier, x equals 120. The output is 21 because when we move the 0 to the front, then we move the 2 to the front, it'd be 021. We're not returning 021, we're just returning 21. So we have to keep track of that as well. So now that we understand the question, y'all, let's get into the fun part, the actual solution. The code is not that long. We should get through it fairly quickly, so let's get started. Now, the first thing we need to do is we need to initialize the result to keep to 0, and we'll keep x mutable. And what I mean by that, first we need to declare a variable. We'll open up the parentheses, and the variable is going to be r comma x. Boom, right? And we're going to set that equal, so it's like a tuple, and we're going to set that equal to, open up the parentheses, 0 comma x. So once again, what I mean is the initial r we're going to set to 0, but we're going to keep x as mutable. Boom. Now we need this loop until all digits have been processed. So in order to do that, we could say while x exclamation point equals 0. So while x does not equal 0, we're going to we are going to open up the brackets, and we're going to say r equals, open up the parentheses, r times 10. Then we're going to come outside of those parentheses. We're going to say plus, open up more parentheses, x mod 10. And what this right here is going to do, this is going to extract the last digit of x and append it to r. So x is going to represent the integers that they give us, right? So, and what this is going to do is going to look at x, and it's going to extract the last digit. So whatever that integer is, in this case it'll be 3, and it's going to append it to r. So then we're going to append it to r. Boom, right? Then we need to remove that last digit from x so we don't do it again within our while loop. As our while loop repeats, we don't want to have the same last integer, right? So we need to remove it. So in order to do that, we could just say x dash equals 10. And what that's going to do, that's going to remove the last digit from x for us. Now we need to check if the reverse number exceeds the 32-bit signed integer range, and if it does, we return 0. If not, we just return our result. So for that, we could come outside of this while loop, and we're going to return our less than sign. We're going to say int 32 min, or, excuse me, so 2 vertical lines, or r is greater than int 32.max. So once again, what this is going to do is it's going to check if our result is less than the 32-bit integer range or greater than the 32-bit integer range, right? So because remember, we do not want to go out of that range. It says if reversing x causes the value to go outside the signed 32-bit integer range, then we return 0. So this is going to check to make sure r falls inside of that 32-bit integer range. Then we come outside of that, we can say question mark, and we're going to say 0. So that's how we're going to return 0 if it falls outside of this range. If r falls outside of this range, which is our result, we're going to return 0. That's with this question mark. So if it does, but if it doesn't, then we could just return r. Boom. So let's go through this code one more time just so it makes sense to everybody. We're going to declare the variable r, or a tuple variable r and x. And what this is going to do, r is going to store our result, and x is the integer that they give us. Boom. Then, so we're going to set r to 0 just to start as a default value, and we're going to keep x mutable. So, because remember, we're going to be mutating x when we change it, when we reverse the order of it. Boom. So what this is going to do, this right here, we're going to loop through all of the digits until all of the digits are processed. We're going to come right here, and this is going to extract the last digit of x and then append it to r. So that's going to take this, say we have r, say we're doing this example right here. Excuse me, take this, copy that. Say we take this example right here. This line is going to extract the last element, right, and append it to r. So now r will have r will have the 3. Boom. Then this right here is going to remove the last digit from x, because remember, we're going to loop through x until there's nothing else to loop through. So boom, this right here is going to remove the last digit, so we can remove the last digit. Now we're still going through the while loop. So then we do it again. We extract the last digit and append it to r. So boom, this time we take the 2, append it to r, boom. Then we come right here and remove the last digit so it's not included in the next loop. So move the 2. Now it's only one digit left. So we're going to take this one digit, we're going to extract it, append it to r, boom. Then we're going to look right here and we're going to move the 1. Now you can see x is 0. There's nothing left, so we are going to stop our while loop. Then we're going to check to see if r is less than or greater than or falls in between our 32-bit integer range. That's what this checks. If it does, if this ends up being true, we're going to return 0, meaning it falls outside of the range. But otherwise, we're just going to return r, just like that, y'all. So that should be all she wrote. Let me get rid of this before we submit it. Boom. Now let's go ahead and give it a run. See what happens after we run it. And it's accepted, y'all. So let's go ahead and submit it and make sure it stays accepted after we submit it. And look at that, y'all. 6 milliseconds beats 44.66% of users with Swift. Not too bad. We could get those numbers up, but we'll focus on getting those numbers up as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem that is presented to us. I feel that this is a good problem to try to solve. It's important to know the formulas, which will help solve the problem. But with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.